Episode 4, Resolving to Do Better. In the last episode, we introduced the first stage in a web crawler pipeline, resolving a domain and service name into an IP address and port. But we weren't really doing any true async work, nor could we handle unresponsive services. Today, we'll fix both problems. As we'll see, timeouts become even more important once several requests are in flight at once. Our new resolver will read a list of domains and services from a JSON file, then kick off all queries in parallel. To parse the JSON, we'll write our own JSON parser from scratch. Not. Could someone please tell me the fifth rule of programming? That's right. Never, ever write your own parser for a widely used standard. To parse the JSON, we'll use the well-tested JSON for Modern C++ library. Another great Hunter feature is the build cache. Since Hunter root defaults to home.hunter, the build system can reuse artifacts from other builds as if they were local. We don't even need to use the magic of internet video to speed up this build. We'll compactify some verbose code with these shorter names. Domain and service names will come from an outside file. The new line delimited JSON spec is available at ngjson.org. It is a convenient format for storing or streaming structured data that may be processed one record at a time. If everyone could just replace their homegrown CSV writers and parsers with ngjson, the world would be a happier place. Anyway, we need to open the file and read it one line at a time. Just like the last episode, we'll make the service name optional. All target sites have been read into memory. Now to queue up queries with the resolver. The async resolve API takes a const reference to the query object. This means the Asio library might make a copy of the query, or it might not. It would be nice to know for sure. Skimming through the online docs unfortunately doesn't provide any clues. Stack Overflow suggests that arguments passed to Asio by const reference are copied when needed, unless the docs say otherwise. But it would be nice to have an official spec that all Asio implementations can adhere to. Print out all the endpoints associated with the domain and service. The documentation guarantees at least one result when successful. Now to find some sites to resolve. Excellent. DNS is quite fast when it works properly. Now, what happens when we add a bad hostname? Not good. In the real world, long operations need timeouts, so users aren't left staring at a screen wondering what's going on in the background. Timeouts are also critical for the reliable operation of automated systems. Let's give ourselves a hard time limit of 3 seconds for all queries and discard results that arrive late. What happened? It looks like looking up the bad host took too long, causing the timer to cancel the remaining queries. But why didn't the long query get aborted as well when calling resolve or cancel? Turns out this is a question that's been around for over 10 years. Let's leave a comment so that developers of the future aren't so surprised when they eventually run into this problem too. Note that this will only cancel the queries which are still queued. Executing queries will be allowed to finish. See the Boost mailing list for more info. That completes the first stage in our web crawler pipeline. Stay tuned. We'll cover HTTP GET operations to fetch web pages, HTML parsing, and more next time. If you enjoyed this episode, please like this video or leave a comment. And don't forget to click subscribe to catch the next episode. Thanks for watching.